Hello kids, this is a revision lesson for Unit 7, which is Diet and Nutrition for Grade 7 Science. Let's get into this. So the first topic in this is the nutrients. So what are nutrients, right? So when we talk about nutrients, right, we mean food, or you can say ingredients, right, uh, that help us uh, grow, stay healthy, and uh, you know do activities, right? So this is why we need food or nutrients, right? Because our bodies require energy to do work. Energy is required to perform actions, right? So hence we consume food or ingredients to get that energy, as well as it helps us grow. It helps us to do our activities. It helps us to stay healthy, right? And to do our normal body functions, right? To have normal body functioning, right? So for our bodies to function normally, we need nutrients, right? Now, there are several types of nutrients which are important for human body, right? Our book is listing very few of them, so I've listed a complete list. You can pause this video and read these individually. I'm going to just go into the detail, right? Number one is protein, right? It builds and repairs tissues, helps in growth, right? Then we have carbohydrates. They provide energy. They do not help us build or repair anything, but they only provide energy. Then number three, we have fats, which are long-term storage. So we can say this is long-term storage of energy, right? And carbohydrates or proteins, right? We have also have short-term storage of energy, right? So proteins also provide quite the energy, but carbohydrates are the highest in terms of energy. Then we have vitamins, right? There are several forms of vitamins, right? They're kind of like proteins which are available in vegetables, fruits, dairy, and meat, right? Then we require minerals. Minerals are other salts and stuff that we require. You can say elements that we require, right? Out of the minerals, we are studying calcium and iron at your in your course. So calcium, it builds and maintains strong bones and teeth. Iron is important for the formation of hemoglobin for oxygen transport. Vitamin C is very important for the immune system. It aids in wound healing. Then we have vitamin D, which facilitates calcium absorption. Without the vitamin D, our bones are going to have osteoporosis, or not being able to build proper functioning bones, right? So vitamin D absorption is very important. Similar way, vitamin C is very important, right? Absence of uh, vitamin C, right, causes scurvy, right? And this absence of vitamin D causes bone issues, right? Bone or skeletal issues. So then we need fiber. Fiber aids in digestion. And finally, we need water to maintain hydration of our body, right? So these are the main nutrients which are important for our body function, and these are their functions, why we need them, and these are the possible sources which I've listed for you people, right? I've even given this link that I've generated this using ChatGPT, right? So now let's get into uh, storage, right? So energy stores uh, for humans, right? So for human body, we remember this as the sodas, right? So this is the S, the O, the D, A, and S, right? So what is ATP? ATP is energy, right? What we need, right? So carbohydrates, they are short-term storage, right? They're not stored by the body. They're consumed, right? And compared to that, lipid, or what we call as fats, right? They are long-term storage, so our body holds them for longer. Energy provision, slow and steady, digestion. Then it is more effect on cells, right? That means carbohydrates are very quick to to be absorbed by the cells and to generate energy, while fats are not that soluble, right? It is readily digested. Compared to that, fats require a lot of time to digest. Then carbohydrates, ATP yield is the total energy yield. So you can see that the carbohydrates in general produce less amount of energy compared to the fats, right? Since fats are long-term energy storage, so they keep on releasing energy even when the food, normal carbohydrates are consumed. The fat will remain there because it is not easily digested, so it will release energy over time, right? And then eventually water soluble. Uh, so carbohydrates are water soluble while fats are not water soluble, right? Moving on. So what are fats, right? Fats, they are a major source of energy. They are the components of cells of tissues, right? We consume meat and stuff, right? They also help us in absorbing vitamins as they provide uh, you know uh, uh, bodily functions, and usually it's converted from larger molecules into smaller molecules, which eventually turns into our body cells, right? Now there are several types of vitamins, right? These are now vitamins. Now, as I said, your book is listing only vitamin D and vitamin C, but I've listed all the vitamins which are there in the food, and this is a very good depiction of what are the sources, possible sources for such vitamins, right? So for vitamin A, you need carrots, eggs, you know capsicum. Then for vitamin B1, you have red meat, you have got wheat, you've got eggs. Then for vitamin B2, you rely on dairy products and peas, right? And for vitamin 5, B5, you depend on broccoli, right? Then B6, from corn and cabbage. B9 from bananas and apples, and B12 again from red meat, and B15 from watermelon, lemons, right? And then E and F are provided by wheat and grain, and other you can say ascorbic acid or vinegars, right? And then we have vitamin H, which is provided by mushrooms, dairy, and chocolates. Vitamin C is provided by citrus fruit, right? As you can see, the orange and the lemon. And vitamin D is provided by fish, avocados, eggs, right? And vitamin K, again, we need some vegetables as well as fruit or vegetable vinegars. And then finally, vitamin P, which is found in some mushrooms and tomatoes, right? So is a complete detail of type of vitamins that we just looked at, and this is again not part of your syllabus, so I've highlighted the most important ones as of additional information, right? This is additional, so I'm not going to go through this as a whole, but I would definitely go through vitamin A, which is very important. It supports vision, skin health, and immune functions, right? The sources are carrots, sweet potatoes, spinach, mangoes, eggs, right? Then we have vitamin B12, which is cobalamin, right? It is critical for nerve functions, right? For our brains to function and production of DNA and red blood cells. So without this, our body is not going to be functioning properly, right? Protein absorption won't be possible, so your body won't be able to heal or have more blood generation, blood recycling in the body. So the possible sources are meat, fish, dairy products, fortified cereals, right? Then we have vitamin C, which is the ascorbic acid, right? It supports immune system function. It aids in wound healing and enhances iron absorption, right? So without this, we won't be able to have iron absorption, and without iron absorption, we won't be able to have hemoglobin production in the body, and hence we will have anemia and other issues, right? So vitamin D is also very important. It facilitates calcium absorption and supports bone health, right? And the sources are sunlight, fatty fish, fortified dairy or cereals, and finally vitamin E, which acts as an antioxidant and protects cells from damage. Nuts, seeds, oil are the main sources for vitamin E. So what are antioxidants? Antioxidants, as you do know, that when we age, our hair grows white, right? So it is due to the oxygen, right? Oxygen causes aging, right? and hence we have antioxidants, right? You must have seen some green teas and whatnot available in the market claiming to be antioxidants. So those help, in providing you vitamin E, right? Vegetable oils, right? And other seeds, right? And because of that, our body has less aging effect compared to people who are not taking these antioxidants in a regular manner, right? So these are some of the sources for their functions. Now, for iron, calcium, and water. Now, these are the minerals that we use, right? In which iron is essential for hemoglobin, which carries oxygen to the blood, right? These are the sources like red beans, red meat, poultry, fish, beans, lentils, fortified cereals. Then for calcium, it is vital for the development and maintenance of strong bones and teeth. Also plays a role in muscle function and blood clotting, right? So the dairy products are the major source, and then we have leafy vegetables and fortified plant-based milk or tofu, right? Finally, water. It is essential for various bodily functions, including digestion, nutrient absorption, and temperature regulation and waste elimination, right? Water, fruits, watermelon, any watery foods will have a lot of water content in it, which can provide for the requirement of the water in the body, right? We usually also drink at least eight glasses of water each day to stay healthy, right? So now two things why I'll come back to these keywords, right? One of here is the anemia, so we'll come back to this in a while, right? So let's move on. What is a balanced diet, right? So what's on your plate? So what is a balanced diet, right? It is a diet that we require, right? A diet plan that provides uh, all required uh, nutrients, right? We just studied nutrients in uh, you know we can say for proper body functioning, right? So we need uh, a diet plan, a proper diet, which will provide us enough nutrients or required nutrients in a proper manner for our body to work in a healthier way, right? So as you can see that vegetables is one of the biggest sections in all of this. Then we have fruits, then we have grains. So these are the three major sections, and then we have dairy, right? And then finally we require a little bit of meat and oils to be the least, right? So oils are not good, but they're required, but not good in excess, right? So excess consumption of oil, right? Fried articles and stuff, they are not good for your body because they leave a deposit and they leave fat which is not soluble, right? Also, it fulfills our dietary urges, but because of that we are not able to consume other foods in a regular manner. So if we take more fried articles, right, then we won't be able to eat much from the other domains, right? And remember that your plate must be of this much ratio, right, where you can see that the vegetable has the biggest, then grains, and then fruits are these are the three major components of your plate, right? You can say about more than 75% is just from plants, and then remaining is from you can say 20% is from dairy and meats, and only 5% from oils, right? So this is on average, for different institutions, different hospitals, different medical centers, they have different ratios for these, but this is the one I like the most, right? And this is a very balanced diet. And why do we need to eat well, right? This is a complete plan where you can see that on food articles, when you buy some from food article or packed food, you must check the label that what is the level of energy that is going to provide, how much fat it contains, how much sugars it have. Uh, do you need to understand that the sugar needs to be at a lower level, right? It fulfills our energy requirement and helps us feel satisfied, but it does not compensate for rest of the ingredients. So having too much sugar in your food is also not good for health, right? We also require some salts, right, as minerals to do our body functions, right? This is another perspective of the same thing where you can see again the vegetables have the largest area, then we have the grains, and over here they have mixed up fruit and vegetables together, and they have mixed up other grains and basic uh, you know cereals in there, right? And then finally we have the meat and your dairy products, and finally oils, as you can see, still the smallest region. That shows that we must consume less amount of oil or less oily products, right? We should rely more on these for our energy requirements, right? More on these for our vitamins and minerals, and eventually these two for body development, right? For growth, right? uh, in general, per day, for adult male or adult female, an adult female requires about 2000 kilocalories of energy, and for men, it is about 2500 kilocalories, right? Again, I've copied the same table from the previous topic, just for the reinforcement. You can pause this video and have a read through these just to reinforce why and these nutrients are required, what are the basic functions, and what are the sources, right? So if you just go through these, this will help you understand why these nutritions are required in a specific manner, right? Now we also get to chart uh, energy uh, sources, right? So we usually like to chart them, right, in a manner that we use food, right? Food, and then we have percentage, component, right? Uh, and then we can go with energy provided, right? So uh, So let's say we have several foods, or you can say just components, right? Food component. If we just go for it, like let's say bread, right? So bread it has a certain amount of carbs, right? It also contains some proteins, right? Some small amount of proteins, and then finally fat, right? Usually we compare just these three for their energy evaluation, and over here we do know that the carbs have most energy, right? Uh, and this is long-term energy store, and proteins are you can say also provide energy, but also require uh, you know helps in growth of the body, right? So this is what we have discussed so far, right? There are several components, several ways you can chart, right? This is the component wise, in which just one article is divided into its components, right? And then we also compare foods, right? For their right, let's say food type, right? And then we have mass in grams, right? And then we have energy in kilojoules or kilocalories, right? So we have two units for energy. One is kilojoules, which is a smaller unit. Kilocalories is a bigger unit, right? So different foods have different type. For example, nuts, bread, right? And then we have meat, right? So meat is going to be, mass in grams. Let's say it's 60 grams, right? Bread is 50 grams, and not if you let's say 20 grams. So how much energy is giving, and these are not the values. I'm just using arbitrary values over here, so these are not the real values. You can check the data from the book, right? Data from book. So keep in mind that you must use the values provided in the question, or given in the book, right? You don't need to memorize these values. Reason being that most of the cases, the questions will provide you this data in a tabulated form or in words, and which you can use to translate your energy calculation, right? So let's say if someone eats this much, so what is going to be the total energy, right? So we can go for, like, let's say if 20 gram generates 104 kilojoules, right? Bread generates 200 kilojoules, and meat produces 180 kilojoules. So it roughly estimates to 484 kilojoules of energy, right? So for energy conversion, now, unfortunately, this energy conversion is no more in your syllabus, but we have seen in the assessment that some of the questions that require energy calculations, right? So, I'm just going to go through this, although this is not part of your syllabus, but in case if such a question comes out of the course, we should be able to handle that. So, it's very simple calculation. We call it as a factorized calculation, right? So that means it's just a simple factor that you need to multiply with. So for 1 gram protein is equal to 17 kilojoules, right? So it generates that much amount of energy, right? So 1 gram of fat produces 34 kilojoules, right? Which we say that twice as much, and 1 gram of carbohydrates, or carbs as I call it, also generates 17 kilojoules, right? So this is a simple factor. Let's say we have let's say we use a toast, right? uh, a child eats a toast, right? The total mass is toast of 20 grams, right? Now, uh, for a toast, it contains, let's say, 60% carb, right? It's since it's bread, so it must contain more carbohydrates. It's got 25% protein, and then eventually it has uh, 15% fat, right? So how much grammage is there? We just need to tabulate this, right? It's very simple that we can say percentage. Although, as I said in the questions, you will have the tables available for you, and we can say mass in grams, right? Small g. So if we break it down, right, how much grammage is there, and then we can go for our energy calculation, right? So let's say if has carbs, the proteins, and then fats, right? So we do know that by percentage it is 60%, right? This is 25%, and this is 15%. And now simply we do know that overall we had 20 gram, right? 20 grams. So for 20 gram, out of 20 gram, the 60% is this, right? So this is very simple. It is 20 into 60% divided by 100%, right? Gives you the grammage. So this is how it's going to work out. It is going to be 12 grams, right? So how much mass by carb is there? It is containing 12 grams of carbohydrates, right? Now for the protein, it is going to 25 into, sorry, right, given mass, right, which is going to be 620, which is this total mass of the toast we're eating, right, into the percentage, which is 25%, divided by 100, right? So this goes like this, to 1555, right? So this is only 5 grams. So 5 gram is protein, and remaining you can identify that remaining amount is going to be just 3 grams, right? So why is that so? Because the total mass needs to be 20 grams. So you add them up, you must get the same amount of food that you're eating, right? We're eating 20 grams of toast. Now, in some questions in the workbook, we found that not all of mass is listed, right? So if not all mass is listed, then what to do, right? So remember, that your food contains, let's say, if 100 gram is there, so you have carbs, you have proteins, right? You have fats, and then some other factors. These are the main ones. Then we have minerals, right? Like calcium and iron. Then we have vitamins, right? And finally, when we're done with all these, we can simply list down our water, right? So if all of these are not adding up to 100, then the remaining mass, right? The remaining mass goes here, right? And this works the other way around as well, right? This should be major, right? Major part of this, and these two are minor part of it, right? Some quantity, and the remaining mass would be, right, this. So they all should add up, the mass of all these should add up to 100 grams, right? This is just a general understanding. You're not supposed to be calculating any of this. You're just supposed to identify which one is missing, right? If they just list these three, then you can say that the remaining mass, if not equal to 100, if not adding up to 100, then it should be containing minerals, vitamins. If these are also listed, that eventually it's the water, right? We had two questions in the assessment quite recently in which this was listed in one question, and you could have used either of these three. And in the second question, these two, major and minor, were listed and water was missing, right? So you had to write water as the remaining ingredient, right? Now, for energy calculation, since we calculated the mass previously, right? So if you remember, I just gave you the formula for energy calculation, right? Energy in kilojoules, right? So how much kilojoules of energy is produced? As you can see, protein is 17, carb is 17, and fat is 34. So for each gram, it is this much, right? So it would be 12 multiplied by the factor, right? It is again 5 multiplied by the factor and 3 multiplied by the factor, right? The factors that we just listed over here, right? This is in kilojoules. Also, it's in kilocalories. You can see that. You can look it up on the internet. But as I said, these are out of the course. But in case if these questions come around, I will be compensating for these questions, right? So keep in mind that this is how you can calculate the total energy as well, right? So if I go for, let's say, let me grab my calculator real quick, right? So in case if you're looking for uh, the total energy, so this is going to be 204 kilojoules produced by the carbs in the piece of toast, right? And then by the proteins it was having, it is going to be 85 kilojoules, and finally uh, our fat in the bread, kilojoules, right? So I can simply sum them up and get the value, right? So let me just sum these values. So it comes out to be 391 kilojoules. So that is the amount of energy that this 20 gram of toast is going to give me, right? So this is how the calculations were supposed to be done, but unfortunately, as I said, it's not part of our syllabus anymore, and the questions that you saw in the assessment were from the previous examination curriculum, right? And they're no more part of our new syllabus, so I do expect some of the questions to come, but in case, as I said, if such questions come, you should be able to do basic calculations in terms of kilojoules, right? I've given you these factors, so you have to memorize these factors, right? For the protein, the fat, and the carbs, right? So you have to memorize these factors. Whatever the grammage is given, you simply need to multiply it with this factor, right? So just multiply that. As you can see, I did for 12 grams. It was a 17 for the carbs, right? And the proteins. So whatever the grammage you have in a specific food, you just need to multiply it with the factor to get the energy, right? Where you can see the carbs and the proteins are generating same amount of energy. It's just the fat which is generating twice as much, right? We just saw that in the previous slide as well, that this is how the calculations work, right? Now moving on, growth and development, right? So what is growth and what is development? Now when we talk about growth and development, you need to understand that the growth is both physical, right? That the body grows, and mental and cognitive. Then we have emotional, and then we have social, right? So if I if I want to chart, then I can say that from a baby to a toddler, right? Then we can say a child, right? Then we have teenager, teenage, right? And after teenage, we have adults, right? Sorry, I'm saying, right? So if you say that in terms of years, you can say from 0 to uh, 6 months, right? And then 6 months to you can say 3 years or 2 years, right? It varies a little bit, right? It's just a range. Then from 3 years to 3 years to you can say up to 11 years, right? That's a child. And from 12 years, which is a teenage, when the teenage starts, right? We can make it 12 over here, right? So from 12 years, and from 13 to 19 years, that is the teenage, and after 20 and onwards, right, is the adulthood, right? So over the course of time, the dietary requirements change. Obviously, the baby is going to require least amount of energy. Then the toddlers have more energy requirement. Child needs more because they're growing, and then teenagers require a lot more because their body development is going at a very fast rate as well. Although, if you compare the rate of development, then these stages are the faster ones because you grow faster, and as you go from child to teenage, your growth slows down a little bit, and once you're adult, you're only aging and you're not growing much, right? So uh, in terms of body development, we have physical growth, bone development, muscle development, right? Organ development. Then for mental, we have intellectual development where you're able to learn, right? For example, if we talk about babies only have body development, physical growth. Then we talk about toddlers, they start to develop some intelligence, right? They learn to move about, they learn to move things around and think a little bit. Then children, small kids, they're able to think. They develop emotional intelligence as well, right? They're able to correspond to emotional queries, right? And then eventually teenagers, when you're developing the sense of the right and the wrong, and then when eventually you become an adult, you're able to understand and comprehend life as a whole, and then you can make concrete decisions for your life as well, right? So these are just the emotional as well as the mental development, right? And then social interaction is definitely over time. The baby, when becomes a toddler, learns to interact, and then from toddler to child, the interaction increases. From teenager and then adult, the interaction keeps on increasing till you form a social circle, right? Now, stages of cell development, right? So this is stages of cell development, right? So when we say that our body is growing, what really happens is that if we have a cell, right? This is a cell in which we see that the chromosomes or the genetic material multiplies, it becomes two, and when it becomes two, the cell divides, right? This is now cell growth, right? This is when the cell is growing, and then this is what we call this intermittent state is called cell division, right? Now, this process called mitosis, in which the cells divide and grow to form new cells, right? So from first to the last, as you can see, it's not just like the original cell, but now we have two of these cells, and once they're going to divide, it will form four cells, right? And they keep on multiplying while our body is growing, right? So this is just a little bit recap of the development. Unfortunately, we did not see any questions regarding this, but we have studied this in the classroom, right? Finally, uh, the skeletal structure of a human body, right, where we discussed some of the body movement functions produced by this exoskeleton. So our human exoskeleton contains 206 bones, right, which are divided into two sections, right? So one is the axial skeleton, right, which is this skeleton which contains the upper part, or you can say the major central body, uh, right, that holds up all the critical organs, right? So your kidneys, your heart, your lungs, your liver, your brain, all the critical organs are protected by the axial skeleton. Then we have the appendicular skeleton, which is movement oriented, right? So this only contains, we can say, muscles, right? No critical organ, right? This one contains organs, right? Critical organs, and protects them, right? So what are the functions of these? We can go into detail of each one of those. I'm just going to skim through them, right? So if we talk about the cranium, which is the skull, right? The cranium has 8 bones. Skull in total has 22. Your cranium, the top part of the skull contains 8 bones. The face has 14 bones, making up to 22. Then we have the associated bones, which are the ear bone, the hyoid, right? 7 of these, and then we have the rib cage, right, and the sternum. Sternum is this middle part that is joining, uh, uh, oh, sorry, the whole thing got right. Okay, fine, it looks better. So we have the rib cage and the sternum, which joins these ribs, right? Then we have the vertebrae at the back, and the sacrum, right, which is the lower part of this, rib cage, and then where we have the coccyx, which is the ending part of our vertebrae, right? Then this is what we call as a thoracic cage, right? Which contains all these you know uh, vital organs. Then we had a vertebral column, right, and the skull, right? So our axial skeleton is divided into 3 parts: the skull and the bones, the thoracic cage, and the vertebral column, right? Now this is the organ protection system that we have in terms of our bones. And then we move to the appendicular skeleton, which is the movement oriented part of the skeleton. And our topic is mostly on the movement, so we'll discuss several types of joints as well, right? How these bones move. So if you look at the appendicular skeleton, we are considering the arms, the hips, the legs, and the feet, right? And all those bones which are associated with movement. Right now, the rib cage doesn't move. Vertebrae is the only part of the axial skeleton that does move. Other than that, there's not much of a movement, right? In the body. Rest are moving parts of the skeleton are appendicular skeleton parts, right? So it's the vertebrae in the axial skeleton that moves. Rest goes over here, right? Now we have these common, parts, which is the scapula, which we call as the beauty bone. Then the clavet, which is that joins the neck and the shoulders. Pectoral girdles, right? These are the shoulder bones we have, right? Then we have the humerus, the radius, and the ulna, which are the upper part of the arm, right? Then we have the carpal bones, which are the finger bones. Then metacarpals are the digits that we have, and then the phalanges, which are just at the tips of these fingers, just the final bones, right? Uh, in the lower limb, we have the femur, which is the major bone. Then we have the patella, which we call as the kneecap, right? Then we have tibia and fibula, which are these 2 parts of the bone, which is in the lower part of your leg, right? And then we have tarsal bones, which are we call as uh, the ankle, right? Bones, right? It's a combination of bones that form of the ankle and the movement assembly, right? Then we have metatarsals bones, which are, you can say, the feet bones. And that we have phalanges, again, just like the hand, which form the digits and the sub parts of our skeletal system, right? Now you need not to get confused, because this is a more complex uh, skeletal structure that I have explained in the book. It is a very simple one that is there, right? Now, uh, moving further, we have parts of skeleton which move, right? As I said, this is the appendicular part of the skeleton, right? The appendicular, which moves, right? So those motions are created by joints, right? Joints are where 2 bones meet, right? Where 2 bones meet, right? And why we have these joints? So that they allow movement, right? So there's several type of joints. There's six types, right? One is the pivoting joint, which is like your neck, which moves around, rotates, right? Then we have the hinge joint, like your elbow, right, which you can move in just one direction, right, back and forth. Then we have the saddle joint, which can rotate a little bit, just like your wrist, right? Your wrist has the saddle joint, and the fingers. And then we have the plane joint, just like your feet in the ankles. And then we have uh, the condyloid joint, which is also in the hand, which allows multi-axis rotation, right, of the hand. And then finally we have the ball and the socket joint, which is in the shoulder and at the hip bones, right? So uh, remember these locations. I will write these: hip and shoulder, right? And then we have uh, these in arms, right? Uh, what we call as wrist, right? This is what we call as finger joints, right? Neck, and then these are elbow, and the same one is also there, right, in the elbow, hinge joint, and knee, right? Both of these contain the hinge joint, right? And the plane joint are in the feet, or we can say ankle, right? So these are just the bones and their specific joints. You can search it up in the book. Right, we have discussed this already in this critical learning activity in the class, that how these joints work, and we made some questions for these as well. Right, we asked each other questions regarding how these functions, where these joints are found. Just try to go through these indicators that I've made. You just need to try and review these, where these joints are located and what are the basic functions, which joint allows what kind of movement, and which bone or which combination of muscles would do this, right? Now, the final topic was type of muscles, right? Type of muscles. So we have muscles, right? These are tissues, right? Cells, they join up together to form tissues, right? It became fissues, right? Sorry, my bad, right? Tissues that form organs, right? So your muscles are organs, right, or tissues which work together in two manner, right? So if I draw a muscle, consider that it is a long elongated tissue which has the capacity to move, expand, right? It can expand to allow certain movement to be done, right? Let's say if this was the muscle, right? Just to give you a little bit color. And it can also contract compared to the original form, right? So let's say if this was, right? So this is now contraction, right? So this is contracted, this is extended, right? And this is the muscle, right? So the muscles can contract or extend to provide body movement of the bones, right? It makes the bones move. Now, these muscles are like meaty parts, right? Meaty parts of the body, right? That contract. These are muscles due to neurosignals, or you can say signals from the brain. These contract or relax, right? We can say this as relaxed as well, right? So to provide body movement. Now these muscles are attached to bones with tendons, right? Now tendons are those whitish little part that comes off from the muscle, right, and joins to the bone, right? So this is what tendons look like, right? So this is going to be tendon, and the whole thing, it would be muscle, right? So tendons join the muscles to the bones, right? Now this is a very common name that we have: biceps and triceps, right? Now these are two types of muscular arrangements, right? In the biceps we have a bone, right? I'm just going to draw a bone, right, as well as an elbow joint, right? I'm just going to draw an elbow bone, right? Now, what are the biceps and what are the triceps? It's a combination of muscles. So for a bicep, the muscle is going to be connected like this, right? One from the forward and one from the back, right? So these are the two way the muscle is going to be connected, right? So it's a bicep. That means it has two tendons for each one, right? So if we talk about the biceps, which are the front muscles, and the triceps, which are the back muscles, right? At the back, right? And the front. So these are the biceps. Why biceps? Because it has two uh, tendons, right? Two combination of tendons that join this muscle to the bone. And for the tricep, we actually have extension that goes into two ways, right? So we have one here and two of them here, right? So triceps, there are three tendons, right? That means each muscle, each tricep muscle is connected to the bones using three tendons rather than two, right? So this is the difference between bicep muscles and tricep muscles, right? Now, I will try to go through some of the workbook questions just to reinforce some of these ideas, right? Let me get to the workbook real quick, right? Let me see. Yeah, here's the workbook. Let me get to Unit 7. Diet and growth. I will go through these in a quick succession, right? As I said, some of the topics have changed compared to the papers that we are looking at, right? So we have done most of these. Just to be clear that I'm just going to make just raw connections just to help you understand which goes where, right? So we need iron to make hemoglobin, right? Uh, we need to use respiration in carbohydrates. We need in respiration, right? So fat and oil, no, we don't know. Uh, Vitamin A helps in vision, right? Vitamin D helps in calcium absorption, right? Now calcium makes strong teeth and bones, right? And then finally we have proteins, uh, which help us grow. Oh, sorry. Yeah, there we go. For growth, right? And as you can see, this is sort of an elimination method, right? So vitamin C we require for our body to heal quickly, and then fats and oil we require, you know, store under the skin. So this is, as I said, fat is the storage. So we do know that the fat is stored right under the skin, right? It becomes a sheet. Animals that live in colder regions, they have very thick skin because a lot of fat is accumulated under the skin, unlike humans, right? Now, next question about nutrients. That these are this is what I was telling you, that each type of product has different masses or grammage of this, right? So, which food contains the most protein, right? So you just need to check which one contains the most protein. So that means the highest mass in terms of proteins. So that would be chicken, right? So we can say that chicken, right? And then which contains the most vitamin C. As you can see, vitamin C is there in orange, right? So this is 29, so we can say orange, right? And then how much fat and oil is there in 200 gram of milk, right? Now you do know that in total mass, if you just calculate the total mass of this, so for the milk, you can say that this is 3 plus 4 plus 5 plus 120, right? And then plus 1. This all adds up to the total amount of milk that we have, right? Now, this is for each 100 gram. Remember that. Now, out of which we're talking about, uh, as you can see, read the sentence above in the table just to be sure, right? Why? Because this is the important part you need to look at. That this chart is for 100 gram of food, right? So each one is 100 gram, right? So this is in milligrams. Sorry, that's not to be added here, right? Okay. So if you look at this, so we're supposed to find fat and oil, which is this, right? So out of 100 grams, right, only 4 gram of fat and milk are there, right? So that means if I multiply it by 2, I should multiply it by 2. That means for 200 gram, it is going to contain 8 grams of fat and oil, right? Because this chart is for 100 grams, we're supposed to work with 200, that means twice as much. So this is also to be multiplied by 2, right? Oh, sorry. Okay, now Marcus and Sophia discuss the information in the table, right? Who is right? Brazil nuts contain more calcium than all the other nutrients put together. Brazil nut contains more fat and oil than all other nutrients put together, right? Who is right? Marcus and Sophia. Now, they're talking about two things. Now, keep an eye over here, right? One is talking about the fat and the oil. The other is talking about calcium, right? We need to see which one is right, right? So if you look at Brazilian nuts, right, they contain 60 grams of fat and oil, that is high, right? And the other one is talking about calcium, right? So we need to see if they are right. Yes, Brazilian nut contains the highest amount of food oil, so the second one is right. Now, if we talk about calcium, that is also the highest value in the chart, right? So if you look at this, then we can simply say that both are correct, right? Who is right, or this, right? All the other nutrients put together. Now, put together means if we join them together, right? So we need to sum them up, right? So obviously, if I just add these values, right, real quick, so we need to add rest others and see if they're right. So it would be, let me get this. Sum of all these values, is it greater than 60 or not? And then sum of all these values greater than this, right? So it would be 13 plus 7 plus 36 plus 3 plus 4 plus 9, right? That makes up, uh, right? Okay. That makes up to be 72, right? Which is greater than 60, right? So first one is wrong. Now for the second one, right? It will be 120 plus 40 plus 70 plus 2. So that makes it 232, right? Now let's go to the question again, right? Brazilian nut contains more calcium than all other nutrients put together. Contains all other nutrients put together, right? Now in this case, if you look at this, this is actually a very odd example of what this question is about. Reason being that turns out that both of them are wrong, right? Technically speaking, if you add these up, I'll redo the numbers again in case if I got something wrong, right? Plus 7 plus 36 plus 3 plus 4 plus 9, yeah, 72. So uh, more calcium than all other nutrients put together. More calcium, no, that's not. And contains more fat and oil than other, that's not, right? So now this is in grammage and this is in milligrams, right? But still that doesn't affect, right? Which one is put together. All right, so we can simply say that uh, both are wrong, as sum for both exceed the values, right? This what we just calculated, that if we just add these up, if we just add all these numbers, if it is greater, then they are wrong, which it supposedly is, right? As you can see in both cases, when we add these up, we see that they are wrong, right? Both of them are wrong, technically speaking, right? Now, although they are giving this caution, that tip, look carefully at the heading, right? Uh, there are 1000 milligrams in 1 gram, right? So but the question states that calcium, then all other nutrients put together. So please, if you had any other answers, that's fine. I think this is a troubling question. I didn't see this first, right? I saw rest of the question but not this one, right? So just go over this question. Nonetheless, it's just wrong for both. At my end, in my calculations, both would be wrong, right? Which food would be best who has weak teeth and bones? Explain your answer, right? Which food would be best, right? Now they have teeth and bone problem. That means we need, uh, you know, uh, vitamin D more, right? So which food? Food explanation: any food that provides vitamin D, and we can go with fatty fish, right? So fatty fish can be used, right? And why? Because uh, it has vitamin D that is needed for calcium absorption, right? Okay. Now, if we were to make a selection from this, then it would be Brazilian nuts, right? Now, this question again is not clear whether we're supposed to use the table or just use general information. I use fatty fish for general information, but if we use the table, then the Brazilian nuts are containing the most calcium, right? And that is like, since vitamin D is not listed, so I'm just going with the calcium. But I would rather still stick to this answer, right? Where I'm just giving a generic answer, right? Uh, okay. Summarizing functions. So proteins, we just did this chart. I just showed you this chart where you can fill this up easily now, right? Then fiber in the food, it's giving different grammage. Why we need fiber for for digestion. For better digestion, we need fiber. Look carefully at the table. Which kind of food do not contain any fiber? Which food do not contain any fiber? That would be eggs, the fish, the mutton, the chicken, right? Any other zeros? So we need to mark out the zeros, right? So these are the foods that do not contain any uh, fiber. So we can generally say meat meaty articles, right? Because all of them are meat-based articles like chicken, eggs, and right, or we can say farmed foods, right? Because eggs are farmed. Egg is not a meat, right? But it eventually does come from the farms. So the fish, the mutton, and the chicken, they come from farms. We also farm these animals. Uh, so farm animals produces. Now calculate the calculate the total amount of fiber in a meal containing 200 grams of chicken, right? Now this is very simple question, right? Because we just found out that chicken has no fiber, so it's going to be zero, right? 0 grams. Now for rice, we need to look at the table that this is for 100 grams. Look very carefully, right? So the rice contains three, right? Three out of 100, right? 3 grams in every 100 gram, right? So if we're supposed to calculate for 200 grams, right, then it would be twice as much, which would be 6 grams, right? And then 100 grams of spinach, it's already listed, I guess that is like this one, right? 6 for spinach, uh, you know, so that would be simply 6 grams because we're supposed to work with this. So the total would be 12 grams, right? So if this is a meal that a student, this person took, then it only contains 12 grams of fiber, right? Choose any 10 of the foods on the table. Draw a bar chart to show the mass of fiber in 100 grams of each, right? So I'm just going to, I'm just going to take a snippet of, oh, we went to unit 6, right? Let me just take a snippet of this uh, table, right? Oh, sorry, it didn't work that way. Just a moment. Okay, so just sorry. Yeah. So here's the table, I just took the table from the book. I'm going to use this to draw this chart, right? So I'm just going to select few of them, right? I'm going to select, uh, you know, let's say I'm going to select bananas, red beans, coconut, peas, potatoes, yam, and spinach, right? We need 10. So, or apples. 1, 2, 3, 4, 5, 6, 7, 8. Two more, right? Fries, right? Potato chips. And then we can go with uh, rice, right? So I'm just going to put 10 of these, right? Each one. I'm going to go with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So I will give them numbers from here, right? I will call it 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Remember, you're supposed to write the names with them for with the food name. I'm just going to do this, right, very in a very simple manner. So for apples we have 2, so that's where our bar chart is going to end up, right? I'm going to draw these lines later. I'm just going to mark these points, right? For bananas we've got 3, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So it contains 3, so that is going to be at 3, right? This is how high the bar chart is going to be. And then for number 3 we have brown bread, which is at 7, so brown bread is going to be at 7, right? Number 4, coconut, it is at 14, so coconut has the highest amount of fiber, right? That is going to the biggest peak. Then number 5 was potato chips, which is at 2 again, right? So this is where it's going to land. And then for number 6 we have peas at 5, right? Then number 7 we have potatoes. Potatoes contain 3, right? So that's where the potatoes are going to end, right, in terms of the bar chart. And then number 8, it is going to be rice, which is also at 3, right? Then we have spinach, which is at 6, right here, right? And then number 10, which was yams. So yams only contain 4 grams, right? So I'm just going to now create bar charts using this hopefully, if this is not a big one, right? Okay, let me just choose the shape. uh, yeah, I would rather use this, right? Okay, so this is how your bar chart is going to look like. That is one. Please don't mind because I'm using the graphics tab, so it's very hard for me to, oh god, go with the straight lines, right? It's technically very hard. This is a very slippery board that I use, right? So this is how your bar chart is going to look like. Although we have never seen such questions in the assessments nor in the paper. I don't know why these questions are there in the workbook in the first place, but I suppose these are important. Reason being that for me the workbook is more comprehensive, hence I focused on the workbook a lot more than the book questions or the assessment type questions, because this is more elaborative. So this is how your bar chart is supposed to look like, right? So keep in mind these values, right? This is where these are ending up, so I'm just highlighting that your chart is going to be representing, right? So this is how the bar chart is going to look like at your end, right? Now I can just remove this or just keep it here, right, for now. So energy requirements. What are the two nutrients that provide the most energy for a cell, right? Two nutrients, most energy, right? So you can read from this, if too much, right? This is telling you how to read this, or you can look for this. So what are the two more nutrients? We have carbs, and then we have proteins. And why we call these as most, reason being these are easily digested, right? We Although fat does generate twice the amount of energy, but it is very slow, so it eventually doesn't end up being a very good source of energy because it takes a lot of time to digest, right? A man regularly eats food containing more energy than he uses up each day. What will happen to his weight? He will gain more weight. Why? Because that extra amount of energy not used will be converted into fat and will be stored in the body. Right? Now, this is the bar chart again. What are the main daily energy needs for an 8-year-old girl? Right? This is in megajoules. 8-year-old girl. So that is going to be around 2.8. Right? So 2.8 megajoules, right? You can just simply track these because this is from 2 to 4, right? And 5, so it's nearly 2.8. Approximately how much energy should there be in the food that an 8-year-old eats each day? uh, there be in food uh, that should also uh, be greater because this is the body requirement. So the food she must eat must contain at least 3 megajoules, right? At least greater, right? So we can say greater than required. If you're just going to eat as much as required, so some of it may not get absorbed, and so you will have deficiency of energy. So you need to eat more than your required, slightly more than your requirement, so that if some of the food is not uh, required, then it is there. Okay, why 8-year-old girl requires less energy? Because boys uh, have more body movement than girls, right? Boys run around a lot, so they're more energetic, so they require more energy, right, than girls, right? Okay, moving on. Suggest why on average, an adult woman needs less energy each day than the man. It's the same thing that men have more work. Men have more dietary requirements than female because of the extensive body movement. So for that, men need more energy and women need a little bit less. But this doesn't mean that that's the general trend. It's a general idea. Women who are athletic or girls who are athletic, they definitely require more energy than listed over here because this is for general idea of how a boy girl is differentiated in terms of body movement. But let's say if there's an athletic girl, then she is going to require quite a lot of energy to perform her routine practices for being an athlete, right? Planning a diet. You're going to plan the meals for one day for your younger sister or younger brother. The challenge is to make a meal really interesting and tasty, or sure she wants to eat them. Plan a diet for one day for an 8-year-old girl boy. Make sure that the diet contains some of all the nutrients, right? So I would give them fruits, right? I would give them veggies, right? And I would give them nuts, and then dairy product, right? Some of the dairy, then meaty products, right? And finally some you can say grains, and eventually some fats and oil, right? So how would I make it uh, fun? So I would rather make a salad out of all of this, right? Dairy and grains, I can make some uh, breads or baked articles, right, to make it more tasty. And for the meat and oils, I can go with, uh, you can say, hmm, roasted meat, right? Because people like roasted meat. I don't know about, I'm not much of a meat fan, but people like, uh, baked or roasted meat, right? So this is how we'll make it interesting. So it's a open-ended question, so there's no direct answer. You can write answers, but make sure that you list these basic food articles that contain nutrients, right? Now, interpreting data, uh, right? Okay, now the bar chart shows the information about people who died from 4 types of diseases in European country. The bar shows death caused by smoking cigarettes as a percentage of all deaths to the diseases, right? So those this is between the men and the women, right? So circulatory diseases, digestive diseases, and respiratory diseases. Death was most likely to be caused by smoking, right? For which type of disease, right? Since we're talking about smoking, so that means a pulmonary system or the respiratory system is involved. So we can say respiratory, right? And least is digestive. Reason being, it does impact the digestion system, but not to a lethal level, right? What percentage of deaths from respiratory disease in men was caused by smoking? So, you know, we can read this. This is 39, right? And for every 200 men who died from respiratory disease, how many deaths were caused by smoking? Now, this chart. If you look at the question, right? Uh, is about percentage, right? So if there were 200, right, if 39% out of 100 is there, so it would be double of 39. That would be 78 men, right? Right. How did I do that? This would be 39% into 200 divided by 100, resulting in 78, right? So that's the answer. Okay. What percentage of deaths caused from cancer in women was caused by this? So cancer. So as you can see, for women, that's the line, right? That is 21, right? This was uh, sorry, this was for men. It was 39, right? So 21 is a percentage. So we can say 21%. Out of 500, again, this is going to be 21% multiplied by 500 divided by 100. So zeros cancelled. 5 2s are 10, and 5 1s are 5. So it's going to be 105. So 105 women, right? Look at the percentage of deaths caused by smoking for men and women show by the whole bar chart. Draw a circle around three words to make the sentence correct, right? The bar chart shows that the percent of deaths due to smoking greater were greater for men than for women, right? So I'm just going to encircle them. As you can see that the charts for men are greater in every aspect, suggests an explanation why stated in question. Uh, and it's a very open-ended question. Men are most likely to adapt smoking as a habit, right? Because it's usually men who are doing this smoking. I mean, very rarely we see women, doing the same thing. Okay, smoking statistics. Now in this question we will practice displaying data in bar charts, right? So we have to build a bar chart. I'm just going to skip this question. I'm just going to answer these basic questions, right? If a country is not listed in the table, use the internet to find the data. Would be this. If a country is listed, then find the data. Let's take Pakistan, right? So in your country listed, find uh, your country is going to be over here is going to be Pakistan, right? Percentage of women who were smokers, uh, percentage of women who are smokers is 2%, right? And percentage of men who are smokers, that is 22%, right? And then we're going to just draw it out. In which country did the greatest percentage of smoking in 2016? So once you will, uh, 2016, right? Greatest. So we can see that the Chile had the greatest women, right? That's 31, right? And in which country did the greatest percentage? It would be Chile, right? On men, right? Men who. So for men, we have the biggest number as 54. That's Maldives, right? So Maldives. Oh, sorry. That's Indonesia. We have 65 here, right? So 65, Indonesia, right? So Indonesia had the highest number of men smokers. So that would be Indonesia, right? In which country was the biggest difference in the percentage between men and women? Which has the biggest difference? So you can subtract and find which one has the biggest difference, right? So you find the biggest difference between 2 and 65, right? That will result in 63, right? So rest are less differences, but over here again Indonesia has the biggest difference. So women were not smoking. Again, the answer is going to be Indonesia, right? Okay, moving on. Looking up the data, giving up on smoking, you can just go through this question, right? Again, it's an open-ended question. When you read the whole text carefully, choose one set of survey result that you can use to construct a result table and a graph, right? So please go through this. It's a fun activity to do. right? It's not a paper-based question. You won't get a question like this on the paper, right? Because these are open-ended questions, and usually we don't get those in the papers, right? Okay, again, it's on the survey, right? Okay, now moving the body, right? So, who reads the scale correctly, right? So, if you look at this, this is newtons. So, this is in 25 and 30 newtons. So, Sophia is correct, right? Moving on. Aaron now pulls a force meter and use right hand, right? So, for the right hand, the third finger. So we can go write the readings in the correct spaces. So we're going to write these answers, right? So in the right hand, the thumb is able to do 25, 26, 27, 28, 20. Sorry, it's a double one, right? So 26, 27. So it is going to be 27, right, newtons. Now for the first finger, there's no first finger given over here. Okay, okay. And then for the second finger, we have again 21, 22. That is going to be 22. For the second finger, sorry, for the second finger, that is 22. And for the third finger, we have 21. And for the little finger, we have 19, right? So where's the first finger though? Uh, Index finger. Okay, that's the first finger. So that is 28 anyway, right? That was the first one we read. So that is 28, right? So just as I said, it's just view and filling up, right? On the diagram, label the bones. You can use a picture of the skeleton in the learner's book to help you, right? Uh, on the diagram, label these bones, right? So which one is pelvis, right? Okay, here's pelvis, right? Uh, Femur. This is going to be femur, right? And then we have the tibia, right? This is going to be tibia, right? So these are uh, the labeling, right? What kind of joint is a knee joint? We will call it as a hinge joint, right? Right? It's the, if you remember the, yeah, the hinge joint, right? Which can give you just one axis rotation, right? Not all axis rotation. On the diagram, label a ball and a socket joint. Ball and a socket joint would be this one, which is the pelvic one, right? Pelvic joint, right? What will happen to the knee joint if the muscle B contract? If the muscle B contracts, what will happen to the knee joint? It would become straight, right? It will straighten up. Which pair of these muscles are antagonistic pairs? Underline the correct ones, right? So antagonistic muscles, which pair? Uh, so A and B are antagonistic muscles, right? Which work in combination as one contracts and one relaxes to get things done, and the other would be C and D, right? So these are antagonistic muscles. Okay, choosing the hypothesis about the bones, right? This is now about this. Thick bones are stronger than thin bones. That is correct. That is generally the idea. Right? People who eat plenty of calcium have stronger bones than people who do not. That is also correct. Old bones break more easily than young bones. Not necessarily. Long bones break more easily than short bones. That is again not necessarily the case, because short bone may be thicker, a longer bone may be thin. That may break easily. Again, doesn't mean the bones don't age up. So being old doesn't mean that your bones are weak. It only depends of how much you had in your youth time, how much you did that. Choose one of the hypotheses that you have ticked in question number one. So you can pick either the two, right? What will you change in the experiment, right? Just go through the context and then you'll understand. It's again an open-ended question, so I'm not going to mark my answer over here, right? Because any answer, any sensible answer would be correct, right? Now, this is all for Unit 7. I hope I was able to clarify most of these queries and the issues in Unit 7. If you still have any issues, just let me know. I'll try and post things up for you people. Thank you.